Sum of and term of an AP. Let us consider the situation again given in section 5.1 in which Sakila put Rs 100 into her daughter's money box when she was 1 year old. Rs 150 on her second birthday and 200 on her third birthday and will continue in the same way. How much money will be collected in the money box by the time her daughter is 21 years old? Her the amount of money in Rs put in the money box on her first, second, third, fourth birthday were respectively 100, 150, 200, 250 till her 20th birthday. To find the total amount in the money box on her 20th birthday, we will have to write each of the 21 numbers in the list above and then add them up. Don't you think it would be a tedious and time consuming process? Can we make the process shorter? This would be possible if we can find a method for getting this sum. Let us see. We consider the problem given to Gas, about whom you read in chapter 1, to solve when he was just 10 years old. He was asked to find the sum of the positive integers from 1 to 100. He immediately replied that the sum is 550. Can you guess how did he do? He wrote s is equal to 1 plus 2 plus 3 up to 100, and then reverse the number to write s is equal to 100 plus 99 plus 3 plus 2 plus 1. Adding these two, he got 2s is equal to 100 plus 1, 99 plus 2, 30, and so on up to 3 plus 98, 2 plus 99, and 1 plus 100. And that is exactly 101, 101, uh, and and so on 101, 101 up to 100 times. So s is equal to 100 into 101 upon 2, and that is 50 50, 5050. We will now use the sum technique to find the sum of the first n term of an AP. A plus D, A plus 2D, up to so on. The n term of an AP is A plus n minus 1t. Let us denote the sum of the first n term of an AP. We have S is equal to A plus D plus bracket A plus 2D bracket close plus up to bracket A plus small bracket n minus 1 small bracket close into D big bracket close. Rewriting the sum, rewriting the term in reverse order, we have S is equal to A plus n minus 1D plus A plus small bracket n minus 1 small bracket close into D bracket close plus up to bracket A plus D bracket close plus A. It's second equation. On adding first and second term, we get 2s is equal to 2a plus n minus 1 into D bracket close plus bracket 2a plus small bracket n minus 1 bracket close into D big bracket close plus up to so on, and it is 2a plus small bracket n minus 1 small bracket close into D big bracket close plus big bracket 2a plus small bracket n minus 1 small bracket close into D big bracket. So it's and time. or 2s is equal to n big bracket 2a plus small bracket n minus 1 small bracket close t. Since there are n terms, or s is equal to n upon 2 bracket 2a plus small bracket n minus 1 small bracket close into d big bracket close. So the sum of the first n term of an AP is given y as is equal to ny2 bracket 2a plus small bracket n minus 1 small bracket close into d and big bracket close. We can also write this as is equal to ny2 big bracket a plus small bracket n minus 1 small bracket close into d big bracket close. In other words, s is equal to n upon 2 into bracket a plus a n bracket close. Now, if there are only n term in an AP, then a n is equal to l, the last term from third. We see that s is equal to n upon 2 into bracket a plus l bracket close. This form of the result is useful when the first and the last term of an AP are given and the common difference is not given. Now we return to the question that was posed to us in the beginning. The amount of money in Rs in the money box of Sakla's daughter on first, second, third, fourth birthday were 100, 150, 200, 250 respectively. This is an AP. We have to find the total money collected on her 21st century. In other words, the sum of the first 21st term in this AP here is equal to 100, D is equal to 50, and N is equal to 21. Using the formula S is equal to n upon 2 bracket 2a plus small bracket n minus 1 small bracket close into d big bracket close. We have s is equal to 21 upon 2 big bracket 2 into 100 plus small bracket 21 minus 1 small bracket close into 50 big bracket close is equal to 21 upon 2 big bracket 200 plus 1000 big bracket close is equal to 21 upon 2 into 1200 is equal to 12,600. So the amount of money collected on her 21st birthday is Rs 12,600. Hasn't the term hasn't the use of the formula made it much easier to solve the problem? We also use Sn in place of us to denote the sum of an term of the AP. We write as 20 to denote the sum of the term 20 of an AP. The formula for the sum of the n term involves four quantities S, A, D, and N. If we know any three of them, we can find the fourth. Remark: the n term of an AP is the difference of the sum of first n term and sum of first small bracket n minus 1 small bracket close terms of it. In other words, an is equal to Sn minus n minus 1. Let us consider some example. Find the sum of first 22 terms of the AP. 8, 3 minus 2. Solution. Here A is equal to 8 and common difference is 3 minus 8 is equal to minus 5 and n it is equal to 22. We know that s is equal to n upon 2 big bracket 2a plus n small bracket n minus 1 small bracket close into d big bracket close. Therefore, sum is equal to n upon 2 Big bracket 16 plus 21 into minus 5 big bracket close is equal to 11 bracket 16 minus 105 bracket close is equal to 11 minus 89 is equal to minus 979. So the sum of the first 22 terms of the AP is minus 979. Now, summary. In this chapter, you have studied the following points. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number d to the preceding term, except the first term. The first number d is called the common difference. The general form on AP is a plus d, a plus 2d, a plus 3d, up to so on. A given list of number a2, a3 up to is an AP is a difference a2 minus a1, a3 minus a2, a4 minus a3 up to give the same value is other word if a k plus 1 minus a k is the same for different value of k. That point. In an AP with first term a and common difference d, the nth term or general term is given y a n is equal to a plus n minus 1t. The sum of first n term of an AP is given y as is equal to n upon 2 bracket 2a plus small bracket n minus 1 bracket close into d big bracket close. So, if L is the last term of the finite AP, then say the nth term, then the sum of all term of an AP is given y as is equal to n by 2 bracket a plus L bracket close. A note to the listener: if A, B, C are in an AP, then B is equal to AC upon 2 and B is called the arithmetic mean of A and C. Thank you.